Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, what we're going to do is we're going to have a look at a software tutorial, this time though using Minitab as our software of choice. Hope you enjoy it. Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's Minitab tutorial, well, we are going to take a look at measurement system analysis using Minitab. Now, before we take a look at what the software gets up to, let's just have a little discussion about what MSA does. Out in your manufacturing site, your production equipment, your manufacturing equipment is producing a distribution. Now, of course, you would like to see that distribution, but before you can see that distribution, you have to put the components through another process. You have to put them through a measuring process. And the measuring process also has a distribution. So you can never see the original red distribution. So of course that's the underlying performance that you'd like to know. The green distribution adds variability to it, and actually what you see is this dark blue result, which is always bigger than the original result that is underlying it, and the difference between the two is your measurement error. MSA, very simply, what does it do? It quantifies it. It tells you how big the measurement error is. So today we're going to take a look at this technique using Minitab. Now, in order to quantify this technique, whatever software you use, there is a basic methodology that we're going to use, and it looks like this. You are going to identify 10 parts. When you identify them, you are going to select them randomly. Most important that it is random. You do not pre-select. So you are not going to pre-select good ones and bad ones. You are simply going to randomly collect 10 pieces of whatever you're trying to understand. So a measurement system is made up of the machine, the method, the component or material that you're measuring, the environment that you are in, and the person who is conducting the test. That is a measurement system. The machine, which of course you calibrate, might be under control, but the specific task, the specific shape of the product that you're trying to measure, etc., is what's in the 10 parts. This is a specific test for a specific measurement. And then what we're going to do, we are going to give the parts out in random order. The measurement system will make a judgment, come up with measurements. Then you ask the same measurement system to measure again. Something which is very important, the measurement system must be blind to the part number. So in other words, when you give back part number 5, you will do so randomly. So you can give the part out first 1 to 10, not a problem. But second time, give it back in random order And the measurement system mustn't know that this is part number 5. And they have a second attempt to measure it again. Then a second attempt to measure it again. You give them back randomly. Of course, what we would hope for is that we get an identical measurement when we measure second time. Any difference here, of course, is error. Then what you do is you give them to operator 2, and they will do the same thing. They will have an attempt to measure the part again. So you give it out in run order first of all. Obviously you do 10 of these. I'm only writing 5 out. You give it out in run order first of all. Then you give it out randomly the second time. And you're hoping that the measurement system comes up with a similar or the same result. Any variability here, of course, is error. And finally, of course, if you look across this way, you will also get error. So there's 2 types of error. One type of error is within system. One type of error is between system. And that's what the MSA is going to look for. Now, we don't call it within and between. The within system is called repeatability. The between system is called reproducibility. Okay, it would be a lot better if we called it within and between, but unfortunately they don't. But that's where the phrase Gage R&R comes from. It stands for repeatability and reproducibility. So we've got our data collected, and now of course what we want to do is to go to the software and put it in a software table. So let's go and have a look how Minitab does this. So here is a Minitab worksheet, and you can see here is my data in the table form that I collected it. Now, the reason why I want it in table form, common sense says it's easy for me to look across the row and just use my common sense. Am I getting the same result or not? And if you look at this particular pattern here, I'm clearly not getting the same result. So even before I press the button on the calculation, I'm getting a sense of how good or bad my measurement system is. So I've got that in that table. But unfortunately, Minitab doesn't want it like that. It doesn't like me to do that. It wants me to have it in a column of information. So you can see here, look over here, I've set one up and I've typed, you can see this data point, look, has been typed in here. But here we go, look, parts, part 1, first measurement, operator 1, operator 2. Part 2, first measurement, operator 1, operator 2. So you can see that the Minitab wants it in a very different pattern down this table. Now this is quite a strange pattern to set up, but fortunately Minitab has shortened this procedure now because they give you a little wizard that will set this pattern up for you. So if I go to worksheet 2, which is blank, and I'll show you the way that Minitab sets up the column of data for you. So we're going to go Stat, Quality Tools, Gauge Study, and it says create a gauge study worksheet. Now the one we're doing is crossed. This is for non-destructive testing, but the first thing I've got to do is set up this worksheet. So nowadays, the old Minitab, you had to kind of do this manually. Nowadays, we we can do this automatically. So there's a little wizard that helps you to do this. And it says, look, how many parts have you got? Well, I had 10. How many operators did I have? I had 2. I can even name them if I want, which would then put the information in the spreadsheet. I'm just going to leave it as operator 1 and operator 2. And how many replicates did they do? How many times did they measure the same part? Well, they did that twice. So with all of those numbers in the box, if I just press OK, now look, it said part number 1, operator 1, operator 2. So the whole thing is in the right order, and it's put that in a worksheet for me. Now, I've already taken this data and transferred it across. It's a little bit of heavy duty lifting to do it because it isn't in the same pattern or anywhere near the same pattern in the way that I collected the data, but that is definitely, as a table, that's the best way to collect the data. So now I've typed all the data into this spreadsheet, and now Minitab is ready for the analysis. Let's do that. Stat, quality tools, gauge study, and we're going to choose crossed. Let's go there. And it says, okay, where are the part numbers? Now, weirdly, it ought to know this, but it doesn't. I have to tell it. Parts are in the parts column. Operators are in the operators column. And where's the data? It's in the C4 column. So the measurement data is in C4. Now you'll notice, look, there's 2 methods, X bar R and ANOVA. ANOVA is recognized as the best analytical method. It comes up with a better estimate of the variability. However, the one thing I will say, when would you use X bar R? If you don't have 2 measurement systems. So in other words, if you only have one measurement system that's doing 2 or 3 repeats, you can only use the X bar R. The ANOVA will not calculate. So that's the reason why that choice is there, essentially. But the best, providing you've got the data, the best estimate is ANOVA. And then we're going to go, okay. So I've got some calculations here. Just to clarify, the MSA is trying to answer 3 questions. Number 1, is my measurement system any good? Now, of course, if we assume that the answer to the first question is no, then the next thing we want to know is, where is my problem? And finally, what am I going to do? What am I going to do about it? So we're going to answer those 3 questions from the data that I've just generated in Minitab. Let's go back to Minitab. Okay, here's the data that I've created. I'm going to take a look down at the graphs because the graphs are kind of important. So you can see there's lots of information here. If I just pop the graph out. So this is known as the MSA. It's kind of the MSA report there. You can see, look, it's telling you which column of data. And the graphs are very useful for the second 2 questions. Where is my problem and what am I going to do about it? So let's pop that back in because first of all, we need to answer the first question. So, is my measurement system any good? Well, if you look at the statistic here, the gauge evaluation, look, 30% of all the variability that I'm seeing is coming from my measurement system. So this is telling me, I think it said 32%. That component right there, 32%, that is unacceptable. Normally, we want to get this thing down to 10%. Yeah, so 32%, it's being inflated by 32%. So there's question number one. The first question was, is my measurement system any good? No. I looked at the contribution, 32%, not acceptable. Right, where is my problem? Now what I'm going to do, I'm going to look at the graphs. Okay, so before we look at the graphs, we've got the study variation here, which is 32%, which you've said is unacceptable. Now what I want to do, look, where's my problem? I want to look at the repeatability and reproducibility. And I'm going to look at these two numbers here. Now I'm just looking at their relative size to one another. So look how big they are. The repeatability problem is much bigger than the reproducibility problem. So my problem, it's not that I haven't got between system variability, but a bigger problem is within system. So systems are struggling to agree with each other. Now, if you look at the results here, if I just get the results table up and just use your common sense. So what we're talking about, look, is the errors there. We're not getting agreement within system. So both of these systems, look, they're struggling to repeat their measurement. There was quite a large millimeter difference there. There's quite a large millimeter difference there. That's much better. That one's not too bad. Some of these, look, nearly a quarter of a millimeter difference. So they're really struggling to repeat their measurement. That's where most of the problem lies. So if we go back to our questions, where is my problem? Mostly within system. It is within system. It's not to say that we don't have to improve the between system as well, but there is a much bigger component within system. Now, what am I going to do about it? Let's go back to Minitab. So we've decided that it's within system. What am I going to do about it? Well, now what I'm going to do, I'm going to look at the graph. Let's pop this thing out and we'll have a look at the graphs. So the graphs, look, the Pareto at the top is showing you the component. There's the part-to-part variability. You can see I've got a bigger repeatability problem than reproducibility problem. That's what we've already decided. If you look at the operator graph down here, you can see that the results are sitting nicely over the top of one another. What good would look like here is you would see one line because the two operators would perfectly agree with each other. The other graph I'm going to look at is this one, because this one over here is the range between the first and second measurement. The left-hand side is operator 1, the right-hand side is operator 2. What would good look like here? A flat line at 0, because 0 would mean they are repeating their measurements perfectly. Now clearly, operator 1 is much better than operator 2 because the range is much smaller. So if we answer the question, what are we going to do about this? We are going to have to train this operator with a better method, and maybe we'll include this operator in defining what the method should be. So a better standard operating procedure is what's needed here, because this is quite a manual activity that I've used here, and this person could certainly help to train this person. But we don't just want them to help to train, we want them to write a good standard operating procedure that we can give to anybody. So that would be the end of the question. What am I going to do? We're going to have a better SOP. Trained to operator 2 probably with the help of operator 1. And there's the 3 questions answered using Minitab. Is my measurement system any good? Where is my problem, within or between? And what am I going to do about it? So Minitab, it's a little bit more tricky. You've got to set the data up in a template. I would always collect the data using this table, because it's very easy to use your common sense and to look across the row and say, how did we do? Did we get consistency? Or have I got lots of within variability? Have I got lots of between variability? And you can do that very easily with a table before you start. But unfortunately, Minitab doesn't want it like this. So you then have to use the wizard. The wizard makes it much easier now. Use the wizard to set it up, and then you can answer the 3 questions. Measurement system any good? Where's my problem? What am I going to do about it? That's what Minitab does for you. There is MSA using Minitab. Okay, well, I hope you enjoyed that little tutorial on that subject. If you've got any questions about Minitab that you want me to help you with, or indeed any questions about Six Sigma at all, or indeed Lean, please drop me a message either in the comments below. Please subscribe also. But you can also leave me an email. If you send me an email on any question and you need a little bit of advice, I'm more than happy to help you out. And of course, if you want me to come and help you inside your factory fix a technical problem, please drop me a line. I hope to hear from you soon.